Hello students, this is Mrs. Jennifer De Cruz from Lilavati Lalji Dayal High School and College of Commerce. And in today's Science 1 class students, we shall study chapter number 9, carbon compounds. So before starting with this interesting chapter students, let me tell you all that the total weightage of this chapter is 7 marks with option and 5 marks without option. So let's begin with this interesting chapter. So students, in this chapter, we shall cover up the following topics: bonds in carbon compounds, hydrocarbons, functional groups and homologous series, nomenclature of carbon compounds, chemical properties of carbon compounds, that is combustion, oxidation, addition reaction, substitution reaction, and in the end, we will study about macromolecules and polymers. So let's begin with the first topic. That is bonds in carbon compounds. So students, in the previous standards, you've already learned that organic and inorganic compounds are the two important types of compounds. The essential element, students, in all the organic compound is carbon. And all the compound having carbon as a constituent element are called as organic compound. So student, bonding in carbon atoms is not ionic but covalent, that is by sharing of electrons. So students, it is also said that carbon is a versatile element, okay, because the entire living kingdom is made from carbon, okay. Carbon is the basic ingredient of our body, we may say so. So let us study the characteristics of carbon, students. So first, carbon has a unique ability to form strong covalent bonds with other carbon atoms, okay? So this results in formation of big molecules, and this property of carbon is called as the catenation power, okay? So what is catenation, students? Carbon, okay? Since it has the ability to form strong covalent bonds with the other carbon atoms, and this property is termed as the catenation power. Second, two carbon atoms can be bonded together by 1, 2, or 3 covalent bonds, and these are called single bond, double bond, and triple bond respectively. The third property, students, is carbon has one more characteristic which is responsible for large number of carbon compounds, which is called as isomerism. Okay, so let's move on to the next topic, students, of this chapter, and that is hydrocarbons, saturated and unsaturated. So students, hydrocarbons are classified into two types: saturated and unsaturated. Saturated hydrocarbons are also termed as alkanes, whereas unsaturated hydrocarbons are termed as alkenes and alkynes. So students, the compounds which contain carbon and hydrogen as the only two elements are called as hydrocarbon. So the smallest hydrocarbon, students, is methane, that is CH4, which is formed by combination of one carbon atom and 4 hydrogen atoms. The structural formula of ethane and propane is seen that the valences of all the atoms are satisfied by the single bonds. So students, such compounds are called saturated compounds, that is ethane and propane are saturated hydrocarbons. So students, saturated hydrocarbons are also termed as alkanes, as I already told you previously. Moving on to the next topic, students, that is the unsaturated hydrocarbons. So the carbon compounds having a double bond or triple bond between two carbon atoms are called as unsaturated compounds. So students, ethene and ethane are unsaturated hydrocarbons. So the unsaturated hydrocarbons containing a carbon-carbon double bond are called as alkenes. And the unsaturated hydrocarbon whose structures contain a carbon-carbon triple bond are called as alkynes. So students, generally, the unsaturated compounds are more reactive than the saturated compounds. So the phenomenon, students, in which compounds having different structural formulae have the same molecular formula is called as structural isomerism. So let's move on to the next topic, students, and that is homologous series. So what is homologous series, students? The length of the carbon chains in carbon compound is different. The chemical properties are very much similar. So due to the presence of the same functional group in them, okay? So basically they have the present in the same functional group. So what is homologous series, okay? The series of compound formed by joining the same functional group in the place of a particular hydrogen atom on the chains having sequentially increasing length is called as homologous series, okay? So basically they are formed by joining the same functional group. Second one, students, what is functional group? So the compounds, they acquire specific, okay, chemical properties due to these heteroatoms or the group of atoms that contain heteroatoms irrespective of the length and nature of the carbon chain in that compound. Therefore, these heteroatoms or the group of atoms containing heteroatoms are called as functional groups. Okay, so let's move on to the next topic, students, and that is systems of common names. Okay, so here, students, the sources of the names of the first four alkanes, namely methane, ethane, propane, and butane, are different. So the names of alkanes thereafter were given from number of carbon atoms in them. So students, when you can say they have basic IUPAC name, which we will study in the next slide. So two isomeric compounds having a straight chain or branch chain in their structural formula are possible for the molecular formula C4H10. So students, the difference and interrelationship in them was indicated by naming them as N-butane, that is normal butane, and I-butane, that is isobutane. So let's move on to the next slide, students, and that is about the IUPAC nomenclature system. So what is IUPAC? It's the International Union for Pure and Applied Chemistry. So IUPAC students put forth a nomenclature system based on the structure of the compounds, and it was accepted all over the world. So students, there is a provision in the system for giving a unique name to all the carbon compounds. And there are 3 units in this IUPAC name of any carbon compound, that is parent, suffix, and prefix. And they are arranged as follow. We first have the prefix, then the parent name, and then the suffix. Okay. So herein, if you take an example, okay, of CH3, CH2OH, okay, herein the parent name is ethane, okay, and the parent suffix can be termed as ethanol, and the IUPAC name, okay, will be termed as ethanol. Okay. Let's move on to the next slide, students. That is the chemical properties of carbon compound. So first one, students, is combustion. So hydrocarbons, as well as most of the carbon compounds, undergo combustion in presence of oxygen to emit heat and light and form carbon dioxide and water as the common product. So students, the example, okay, of combustion can be taken as methane, okay. So methane, it undergoes combustion in the presence of oxygen to emit heat and light to form carbon dioxide and water. The next chemical property, students, is oxidation. So substances that can give oxygen to other substances are called oxidants or oxidizing agents. So students, potassium permanganate, okay, or potassium dichromate are commonly used as the oxidizing agents. Let's move on to the next topic, students, and that is about the important carbon compounds, that is ethanol and ethanoic acid. So students, ethanol has linear structure, okay, liquid in state, boiling point is 78 degrees Celsius and the freezing point is minus 114 degrees Celsius. An ethanoic acid or acetic acid has linear structure and below 17 degrees Celsius, it solidifies to form glacial acetic acid. Okay, let's move on to the next slide, students, and that is macromolecules and polymers. So students, the giant carbon molecules formed from hundreds of thousands of atoms are called as macromolecules. So students, a macromolecule formed by regular repetition of a small unit is termed as polymer. And the small unit that repeats regularly to form a polymer is called monomer. Okay. So the reaction by which a monomer molecule are converted into a polymer is called as polymerization. So what is polymerization? Wherein, okay, the reaction by which a monomer molecule is converted into a polymer molecule, this takes place and it is known as polymerization. And students, in the end, polyethylene, okay, is a polymer made by the monomer ethylene. Okay, so urine, students, are normal macromolecules. Okay, we can have polysaccharides, then proteins, nucleic acid, and rubber. There are some of the examples of macromolecules. So students, with this, we've completed chapter number 9, carbon compounds. Thank you.